Hello, everyone. Welcome to Hemisphere Gnss. This is our VEGA series webinar, where we're going to talk about our positioning and heading technology on our new VEGA series platform. I'll be doing the presentation today. My name is Kirk Burnell, Product Manager with OEM Boards and Atlas Correction Service. Also available, we have Mark Sprague, our Business Development Specialist, with us on the webinar. And we also have a team available to answer questions live. So you'll notice there's an option for the right side of your screen for chat. Feel free to send a chat message there, and a team is standing by live to direct questions and get answers. The presentation is going to cover an overview of our VEGA series products. We'll look at the technology that it's built on inside, as well as some of the features that we've got available, including our Atlas Global Corrections. We'll also have a look at some performance data and talk to you about support options for integrating VEGA into your next product. Inside the VEGA boards, we have our Lyra Technology, which is our ASIC design. It's the foundation that the VEGA product runs on, and it's our newest offering, new ASIC design, available to track all of the signals in the sky and also provide great options such as interference mitigation and Atlas correction services. We'll have a look at some of these things in details in some of the next slides. Should also note the VEGA series has two platforms. There's the VEGA 28 and the VEGA 40. The VEGA 28 is a 28-pin industry standard footprint, about the size of a credit card. And the VEGA 40 is the industry standard 60 by 100 millimeter 40-pin board, which is a combination of 24 and 16 pins on the connectors. Scalability. This is one of the key issues in the industry, is how do I design a product once and offer options to my customers so I can sell it to a beginning customer or a very advanced customer and have it tune and scale along the way to meet their performance needs without having to spend more than we require to meet those performances. The VEGA series has the option to provide multi-frequency and multi-GNSS constellations to the users. This means that they can have a very basic product, which is single frequency, or they can include multi-frequency and be able to have very high performance. Multi-GNSS allows the receiver to track all of the satellites in the sky as an option. This is very powerful as it helps the receiver work in marginal areas. The design of the boards, why are there so many pins? This offers a lot of integration opportunity for clients to access different features on the boards without having to go through an extensive configuration and setup process, potentially at their factory, in order to be able to bring those features to their clients. We also support free firmware updates. So when your receiver is having a few years in the field, more than likely there's a new firmware available that's going to provide additional features and options and performance enhancements. That's available as something that can be installed, and it's very easy to access. We have a global support team that's also available to help with your integrations. And most importantly, with the VEGA series, you're having Hemisphere's industry-leading heading performance and positioning performance as well. Our new signals in the sky. This isn't necessarily obvious to everyone, but the satellite systems themselves evolve and progress over time. As each system launches new satellites, new signals become available as they go through different phases of their designs. Most notable for the Lyra and Phantom series, which is the single antenna cousin to the VEGA. The Beidou Phase 3 satellites offer some new signals that many receivers aren't able to track, partly because the control documents that explain how these signals are tracked are only available quite recently. With VEGA series, you can take advantage of these new signals, and these signals are in the satellites that are orbiting over all over the Earth right now. With Beidou, there's some satellites that are regional over China and Australia and India, that region. In the other satellites in the Beidou system orbit globally, and those are available for everyone to see worldwide. Most of those are Phase 3 satellites right now. As well, GPS has L1C signal. This is new signal, and C doesn't stand for clean, but that's one of the advantages of L1C, is it provides a very clean L1 signal. GLONASS began launching satellites that are now supporting their G3 signal. And Galileo has E5 Altbach, which is a very wideband signal, much like the Beidou ACE-Bach signal. Wideband signals have very robust tracking techniques employed, which provide very clean, stable measurements. So using these newer signals can provide better performance for your users. And also QZSS as the LEX signals, the L6D, L6E signals in space, and those are available through VEGA as well. Lyra Technology, the Lyra 2 is the heart of the board. It's the main ASIC that does the signal processing. So that central device is what allows it to track all the signals in the sky and use those signals in the position solutions and heading solutions. Lyra 2 is a big step forward for Hemisphere because it manages to increase the functionality, increase the number of signals available to be tracked, increase the number of measurements to be able to use at the same time as reducing power consumption, regardless of whether channels or signals or the number of those, if that means something to you or not. Lower power consumption is something everyone can take advantage of. It provides either longer battery life for portable applications or lower heat dissipation concerns for integrations that involve a more fixed power supply system. The Lyra technology also offers faster signal acquisition because of all the signal structures being managed from within the ASIC. We have very clean measurements available, and clean measurements happen faster. It's also support in there for timing applications as well, with different synchronization signals being available on the different boards. So here's a look at one of our internal documents. I believe this one was for the Phantom, the single antenna version of our newest technology featuring the Lyra chipsets. So this kind of shows a little bit of the power consumption. Sometimes, you'll see a very enticing number on a product sheet, and it's very often just for the L1 GPS only power consumption. So we went through and documented for ourselves what power consumption is at various constellations. As you add more signals and more processing, the receiver has to work harder to do that. So at the end, even with Ethernet turned on, it's just over 2 watts. And I believe for the dual antenna version, it's somewhere around it's under 2.5 watts with Ethernet on, under 2.2 watts when it's using just serial and USB and CAN ports. Lyra isn't the only ASIC design on the boards. The Aquila Wideband RF ASIC, that's quite a handle. What that's for is for the tracking. When the signals come into the receiver, what they're going to pass through is the wideband RF ASIC, the Aquila wideband RF ASIC. That's going to effectively digitize that solution for the Lyra chipset to work from. It's a very important part of the design. It is a large area for power savings, is how we were able to work the design for VEGA. As well as providing clean signals, again, we improve our signal acquisition time, and as well, I mentioned the power consumption. So what does that look like for the user? More signals and more satellites means more measurements in the sky. And most people are maybe familiar with the Skyplot image here. You can see all the different satellites from all the different constellations. And it's very easy to see how missing half of sky due to an obstruction still provides plenty of satellites for positioning, regardless of the orientation. So that's one of the main advantages to tracking all of the signals, is it allows you to go into areas where you may have been prohibited with satellites that are receivers that are maybe GPS GLONASS only. Here, all options being on at the same time gives you maximum performance and availability to get the job done. So at the bottom is a representation of the different signals with all the different colors. And you can see there's a lot of bars there, which translates to a lot of channels on board the receiver doing their job tracking the signals. One of the other features we have built into the receiver is the Cygnus interference mitigation technology. This is, sometimes people talk about anti-jamming or anti-spoofing or interference mitigation. This is the type of task that Cygnus is set up to do. What it does is it monitors your incoming signals. If you're looking to monitor it, it's scientist type of application. As well, it automatically is watching that coming in and being able to use that information to identify interference sources and provide mitigation to reduce the impact of those on your measurements. People might ask, what does interference do? If I don't see a problem with my positioning, is it really a problem for me? The answer to that is basically yes. What interference does is it lowers the quality of your signal and makes noisier measurements. So when you reduce your measurement noise, that improves your positioning quality. The next slide here has a little bit of a video, image to show what that looks like on the spectrum analyzer. The image on the left, we see there is a filter being employed. That's what's putting those deep notches in the signal levels. So it's frequency across the bottom and signal level on the side. So we've got 2 notches set up there that come in and can, I think there are about 55 dB of rejection is being provided there, which means there could be a very strong signal source at that frequency and it's not going to impact our measurement. One of the things we can also do is set up multiple notches as well as a programmable depth, and we can see the notches on the right are multiple as well as being at different depths. So the key is you want to bring in as much signal as possible. That's how we're going to make the cleanest measurements, but we want to remove the pieces that are causing degradation of measurements. And that's why programmable filters are the key to addressing this in a dynamic environment. Just going to pause this video here because there's a lot on this screen to look at. It's one of our technical softwares that we use for tracking satellites. Some of the users may be familiar with this software. In the background here, we have some channel tracking information, which is signal to noise ratios. So I think we can identify those here with the signal to noise ratios being on the L1, L2, and L5 channels. What we're looking at is a L5 frequency, which is identified here. And in this main window, we can see the spectrum analysis of the incoming L5 band. The scatter plot window shows us visually that we're tracking when we have two circles on the left and right side for L5. That's how we can tell that we are locked on channels here. If the circles move to the center as one single circle, that means we've lost lock. So what we're going to do is we're going to inject a interference source into the signal stream. We're going to see that it loses lock on the scatter plot. We'll also see that the signal to noise starts dropping on the spectrum analyzer. And then in the video, this cursor is going to click on the enable the automatic anti-jam, and we'll see the RF digital RF filters from Cygnus come in and recover the true satellite signals in the background. So I'll let the video play here. So we're tracking signal, we've injected, we've lost our signal because we've gone to the center thing. We're going to click on the enable anti-jam, and we'll see our signals come back in and begin tracking like normal. So this is set up to demonstrate this because there's no, in what's happening, enabling the auto anti-jam. If that's set up in the configuration when the receiver's turned on, there's nothing for the user to do here to make this work. They can have this turned on, and when interference becomes present in an environment, Cygnus will turn on the filters, remove that signal, and when the interference source disappears, so does the Cygnus filter and turns back to standard satellite tracking. Very powerful, especially as more and more wireless devices are brought into our environments. And we carry cell phones and laptops and smartwatches, and all of these devices use RF spectrum and bring more and more noise into our environments. And interference mitigation is something that's going to be very important to keeping things running smoothly. Atlas technology. I'm not going to focus too much on the Atlas. It's something that's available on VEGA. Many of you are familiar with it as a hemisphere positioning technology. It provides global corrections. There's multiple levels of corrections available. That's part of the scalable accuracy. Users can choose to subscribe for various amounts of time to receive corrections at various correction levels. They can receive sort of sub-meter correction to provide sub-meter performance in areas of the world where there maybe is no readily available correction source. There's also that's the Atlas Basic. There's also the Atlas H30, which provides a few decimeters of accuracy for users, and the H10 service, which provides better than a decimeter of accuracy. Those sorts of performance levels are available with the VEGA series on either the VEGA 28 or the VEGA 40. As well, the ARTK feature allows the receivers to use when they're running in RTK mode, if that RTK correction link becomes interrupted, either if it's internet-based, maybe there's a problem with the internet connection, or similar, if it's a radio link, maybe there's some radio blind spot that you're operating in. The ARTK signal from the Atlas satellites from L-band, it will bridge that and maintain your RTK accuracy, so you don't drop back to meter or sub-meter level positioning. Instead, you'll maintain that positioning for many minutes until your RTK link is back and established, and you carry on with your RTK performance. It's a very practical feature for users. Atlas Technology, again, here's a look at some of the stuff more numerically. We're going to kind of change gears here and look a little bit more at some plots and some graphics of how this is working. So what you see here is an open sky environment, the Atlas service with 3 of the other L-band competitors out there on the market, and we can see they all have kind of a similar performance from the lock-in state. And once we've locked in and settled in, we hold our performance throughout. So this plot shows it's somewhere around the blue line, somewhere around 700 seconds in, is doing quite well. There's a little bit of a bounce, and then at 1700 seconds, that stays at that level for the rest. It's about a 2-hour time span on the plot here. So, all right. How about VEGA performance? Let's look at some RTK and heading performance. So this is using a 1/2 meter antenna separation. What we see here is 2 sets of plots that look very, very similar. They are not identical. They are discrete data sets. They've been collected with 2 antennas and antenna splitters so that each board sees exactly the same signal, has exactly the same multipath characteristics in the data. And the result we can see is nearly identical performance between the 2 boards. So the message here is that regardless of the smaller VEGA 28's size or the larger VEGA 40, the performance is the same. And that's why we've been talking about VEGA's performance versus VEGA 28 or VEGA 40. So the top is showing horizontal positioning in RTK mode, and then the middle graphs are showing the vertical, and the bottom is showing our heading performance. So at a 1/2 meter, we're seeing just over 0.12 degrees RMS. So as many of you know, when you move your antennas further apart, that heading accuracy improves. The challenge becomes how much space do you have available and how rigid is the body that you're fastening these antennas to. So in this case, we're just showing some sample data that we've done collections on. So it's a lengthy data sets, overnight data sets, that type of thing. We have lots of change in satellite geometry and atmospheric conditions happening through that time. And that gives us a good example of what the products will experience globally. So you can see the specified RMS is listed here because this graph is showing what a sample set of data looks like. And we can see the darker orange regions on the plot are showing up, showing the RMS. So 67% of the data is falling in those darker orange areas. And the wider variations in the graph extend out to I'll say peak to peak over the 16 hours, shows the lighter orange areas. That it's complicated to show actual data plots here because we're talking of hundreds of thousands of data points. So trying to summarize that here shows you sort of bands of what performance to expect. So the blue dots represent the specification put on there for reference. So, all right. It's also about competitive comparison. So in this, we decided we should probably run the VEGA 28 against some of the other competitors on the market. So we're doing some data collection, and again, using 12 to 15 hour data sets, 16 hour data sets. So we used two different things. We used different antenna separations. We used 2 meter and 1/2 meter antenna separations. And besides doing an open sky comparison, we also, on there you can see we've done some very challenging environments where we have obstructions and reflective obstructions around. So we wanted to show what the performance of these things is in these sort of non-ideal conditions. So for that, we see here what the results are. We've got on the left side, the bar chart is showing the clear sky performance, and everybody's meeting their performance in clear sky. There's no question. All of the receivers were able to perform and hit their specified numbers. We can see that there's a difference between the orange bars, which are 1/2 meter separation, and the blue bars, 2 meter separation. We can see that huge improvement in performance by separating the antennas. The rest of the chart is showing what happens in the challenging environments. So we've got 8 different challenging setups, and a graph with the orange dots is the 1/2 meter, and the graph with the blue dots is a 2 meter separation. And I've got them ranked as the most challenging environments at the top, and that's why we can see in the heat maps, we see that there's a lot less green and a lot more red as we move onto the top parts of the charts. And as we progress down, we get to the less challenging environments. So that's not to say that urban canyon is not a challenging environment, but I have a feeling that the receivers have been tuned to address the urban canyon environment, because there's been a lot of opportunities globally for using a dual antenna receiver in an urban environment. So what the orange and blue dots show with their scatter is that as the environment becomes more challenging, the performance can vary quite widely. In all cases, though, the VEGA series is coming out as the winner in all tests, meaning that in a challenging environment, VEGA is delivering performance as best it can and better than the competitors on the market. And I just want to stress here that 2, 3, and 4 are simply the second, third, and fourth best performance, and doesn't refer to a particular manufacturer by those rankings. So all the numbers on here, by the way, are RMS values for heading. So anyways, I want to share some performance real-world comparison data here, and hopefully that helps emphasize why VEGA is a great choice for your integrations. So moving on, part of also choosing Hemisphere, it brings great integration support. We have a dynamic technical support crew assembled to be able to address your integration questions, from electrical to environment to application-based things to theoretical. We also are introducing a new development kit. I think it's visible just behind the text in the image here. The new development kit that can support all of the Phantom and VEGA offerings and provide access to all the pinouts and all the features through the main connectors on the board, as well as jumpers and dip switches for setting the settings instead of dealing with individual jumper connections. I encourage you to reach out to our team. I want to thank you for your attention today on the webinar, and there's some contact information from Mark if you have queries about getting product or having a look at some different information on the products. His contact information is there, and I encourage you to be entering some questions in the chat. We're going to leave the chat window open for at least 10 or 15 minutes here, so feel free to get your information put in there, and the team will work to address your questions. And again, thank you for your time today.